All right, this is Electrical 2, Module 3, Module number 26203-20, Electric Lighting Lecture. PowerPoint's up here. I'm going to dive straight into it. So the first thing they go through is kind of how we see light with our eyes and as it light levels and stuff like that. We've had you'll have I think you had a lighting chapter in Electrical 1, and I know you'll have one in Electrical 3. So stuff just comes back and back. A lot of stuff. Actually, one of my favorite electrical projects is usually lighting projects because you got to do everything, and then all of the last minutes kind of flip the switch, see if what you did works, and then light up a room. Usually people are pretty happy about lighting projects. So not usually too hard and usually pretty fulfilling because everything is hidden away, but everything is bright once you're done. But going into like how our vision works, trade terms, some of those are good to know. You probably have known some of those, you might not. Luminescence. You need to know definitely need to know the difference between reflection and refraction. You're going to have those two some quizzes or tests. But in 110 vision, I've got this second sentence highlighted. Excuse me. Or at least, second sentence. Light enters the eye through a thin, transparent layer known as the cornea. You know what the cornea is. Then passes through the pupil, the opening of the iris that controls the amount of entering light, then to the lens to focus it, and is made up of, it's finally to the retina, sorry. But you want to focus in on that first part where it says cornea. I also have the last sentence of that paragraph highlighted. The nearly 5 million cone cells occur in 3 types and are concentrated near the center of vision, providing color and detail and higher levels of light. See figure 1. This is going to be figure 1 is what's up here on the board, so you can see where you can see different lights along the spectrum. We can only see a very small amount of the light spectrum. That's why we have like infrared or ultraviolet. Those are kind of the two sides. Like you can see purples on one side or violet, and then reds on the other side. So that's infrared is like above what we see in red, and then ultraviolet is further down than we can see in the spectrum as far as the violet or purple colors. The third paragraph, a little short paragraph, still on page 1, first sentence is highlighted. The rod and cone cells send their information through the optic nerve to the brain. Very amazing thing of how we can see colors and light and just see in general. It's a very amazing thing what our bodies can do with light and what we can end up transferring to our brain to actually make visual images. 120, page 2 and 3, characteristics of light. Nothing on page 2. Looking over at page 3, second sentence on page 3 is highlighted. Light, color, or highly polished surfaces reflect more light than darker colored or dull surfaces. So that's why, like usually roofs and stuff on commercial buildings are white because they reflect the light, they don't absorb it. You can look at that picture on this picture that's up on the board that you have on page 3. You can see where your colors come in for like a light surface and they reflect off of them. Dark surface absorbs light, and then transmission would be like a clear pane glass where it passes through, or at least a lot of it passes through. Absorption, reflection, and refraction of light. 122, first sentence is highlighted. All the light striking an object surface will be absorbed, reflected, or transmitted, as shown in figure 3. So that's what I just talked about that's on the board. They have that table at the bottom of percentage of light reflected by common surface of materials. I've got the dark red bricks all the way at the bottom is highlighted. So how much light will a dark red brick reflect? That's 10 to 15%. So So they're going to look darker and stuff because there's not a lot of light being reflected back to us off those bricks. They absorb a lot of that light into the color of those bricks. Flipping over to page 4, light colors. So this is the spectrum of colors that we can see. 1, 2, 3 light colors. Top right of the page, that first that second paragraph on the page, first sentence is highlighted. When all the wavelengths of the light spectrum are presented to the eye in nearly equal proportions, white is seen. So a lot of people think you mix all the colors up like you did back in elementary school with finger paints, you get black or brown or something nasty like that. That is not the case here. If you mix all the or light is presented in equal wavelengths, or when all the wavelengths of light are presented to the eye in equal proportions, you're going to see white. White. Don't know why, but that's a higher miss question. Page 5. That first paragraph on page 5. Fourth sentence is highlighted right after where you see selective absorption. Practically all colored objects owe their color or selective absorption in some part to the visible light spectrum, with resulting reflection and transmission in other selected parts of the spectrum. And it's all about the light spectrum. I'm going to keep going, flipping over to section 2. Sources of light, section 2. In the trade terms, you should know what all those are, but the Color Rendering Index, CRI, is an online test question. It is a measurement of the way a light source reproduces color with a range from 0 to 100. The higher the index number, the closer the colors are to how the object appeared in full sunlight or incandescent light. Some more of these that you might have heard of. You probably heard of a ballast, like a lot of these lights that we have in school buildings and stuff. Fluorescent lights require a ballast, and it's just it's kind of like a transformer. It ramps up that voltage in order to get the stuff moving inside of those fluorescent bulbs. Driver. This is kind of the same thing but different. Not the same thing, but different for an LED. Like a ballast is kind of what makes it a fluorescent light work. An LED driver is what makes an LED light work. So they're pretty important. Like if an LED light's working more often than not, in my experience, I've seen the LED driver be bad rather than the light itself. That's how they can say like these lights will last forever. Like the lights themselves will last like a long time. But it's the drivers that seemingly like the drivers are the ones that are having the problems with keeping up and keeping working and stuff like that. If you ever see like the street lights, the newer street lights that they're putting in, or even if you're in a night class here at Nunez, right now there's a light out back. It's one of Entergy's LED lights, and it just sits there and flashes and flashes and flashes. That's a telltale sign of a bad LED driver. Some of these you should have heard of before, like lumen. They'll talk about lumen maintenance, stuff like that. But just make sure you have that color rendering index marked down as an online test question. Comparison of sources 210. All the way at the bottom, the last full sentence on the page is a online test question. Generally, the higher the CRI, the better it makes people and objects appear. The higher that color rendering index number is, the better people and objects are going to appear to the naked eye. Page 7. Still in the same section. Those first set of bullet points on page 7. The sentence before them is highlighted. Lamps can create atmospheres that are warm or cool in appearance. Everybody's seen that. You can have a warm bulb or a cool bulb. Cool bulb almost looks blue. A warm bulb is made more mimic kind of the sun. It's more of an orange type look. And then I've got all 3 of the bullet points highlighted separately. First one, color temperatures of 3000 Kelvin and lower are described as warm in tone and slightly enhance your reds and yellows. So if you've installed any of these LED lights before, A lot of these pancake lights or pan lights or whatever they have a little switch on the side that lets you switch what the temperature is on the light, so you can go from warm to cool. Second bullet point is an online test question. A color temperature of 3500 K is considered moderate in tone, producing a balance between warmth and coolness. And the last bullet points that were highlighted: cooler temperatures of 4100 Kelvin and higher are considered cool in tone, or slightly biased towards blues and greens. So you need to know that 3000 below would be considered warm, 3500 is a balance, and 4100 and above would be considered cool. We talk about incandescent lamps. If you've never heard of an incandescent lamp, that's like your normal light bulb. This is what they're trying to get rid of. If they haven't already gotten rid of, like, I think they've gotten rid of the 60-watt light bulb, but you need to know, like, this is where the filament, like, current actually passes through here, heats up this filament, and the filament's what creates light. Problem with these light bulbs are they're not very efficient, so they give out a waste. A lot of people know that you turn on a light bulb for an hour and turn it off and go try to take it out. It's going to be very hot. That heat is a loss. Most of the time there's heat in a system, it comes out as loss. But LED drivers, LEDs don't give off a lot of heat, so they don't have as much loss as far as heat goes. Flipping over to page 8, and they have this is going into the advantages of incandescent lamps. They started on the advantages of incandescent lamps. Are available in many sizes and shapes, no ballast, they're dimmable, they offer very high CRI of close to 100. And then on page 8, they go into the disadvantages. So more disadvantages than advantages. I've got the third bullet point in that section highlighted. They have the shortest life expectancy of all lamp types, typically between 750 and 2,000 average hours, depending on the type. The next bullet point is also highlighted. The cold resistance of the filament is very low compared to its resistance when lit. So lamp failure with a bright flash typically comes from a high inrush current of a cold filament. So if you have a very cold room or something outside, we don't have very cold anything down here in southeast Louisiana, but say you had a shed outside and it was the winter and it was actually 30 degrees outside, there's much more of a chance of an incandescent light bulb going bad when you turn it, because the change in temperature is so rapid that material can't expand that fast, so it ends up popping. Online test question is the little paragraph right after that set of bullet points. Online test question. In 2007, United States Congress passed the Energy Independence and Security Act, which mandated the phased elimination of general use incandescent lamps between 40 and 100 watt sizes. So, like I said, I should have known that, but over 10 years ago, going on almost 20 years ago, we're getting rid of these incandescent lamps and moving further and further into the LED age of light bulbs. Now we're going to go into different types of lamps, and these could be for different things such as stadium lights. And just so y'all know, these books are updated every 3 years. I am on the edition 10 book. Light bulbs are something that the technology is rapidly getting better and better for. Down here in southeast Louisiana, if you guys are old enough to remember, not this upcoming Super Bowl, but the last one, like big mishap, lights shut off, right? It took them 20 minutes plus to get the lights to turn back on. That's because of the type of light bulbs they had. Like that was a huge mess up for somebody. But now you can look up at stadium lights and they're LEDs, and you can see them flashing, turning on and off and on and off. It's because they don't have all the heat and stuff that these other types of bulbs have. So a lot of stuff is going to these LEDs, like I said. But 212 tungsten halogen incandescent lamps. I've got the second sentence highlighted on page 9. 2 changes allow halogen lamps to have a hotter filament and a longer life. The addition of a small amount of halogen gas, typically iodine or bromine, and closely encasing the filament and surrounding gases in a fused silica or similar heat-resistant glass. It's the makeup of how they make those tungsten halogen light bulbs. Greater service light. They're very, very hot. Moving on to fluorescent lamps. Talked about these a little bit. 213 on page 10. Right-hand side of the page, that last paragraph before the bullet points, second sentence is highlighted as an online test question. To start the lamp, a high voltage surge is needed to establish an arc in the mercury vapor. So these fluorescent lamps have a mercury vapor in them. Like I said before, it has to have like a high voltage in order to get that stuff going. So that's where the ballast comes into play. So the ballast is what ramps up that voltage from wherever you're. For this room, I think it's 120, but you can have 277 or probably 240 volt lamps. But they ramp that voltage up quite a bit to get that mercury flowing. They have different types of or different classes of fluorescent lamps, and they go through the bullet points starting on page 10 of those. The second bullet point, the rapid start, I've got another online test question, and it's the last sentence on page 10. Rapid start lamps have a bi-pin, so they have 2 pins on the end, or on the base of each end. So that's most of your fluorescent lamps. You can see up here on the board, they got 2 pins on the end. Always, 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 always turn off the lights before you're replacing these lights or these types of bulbs, because if you're touching the pins on these on one end and you stick one end to the other side, that ballast is going to crank up those voltage, and you'll end up feeling it. Page 11, you're going to have different types of fluorescent lamps other than those basic 3. The basic 3 were the preheat, rapid start, and instant start, but they go through on page 11 of some different types. Online test question is the first one. The slimline lamps is a group of instant start lamps with a single pin base. Online test question. Next bullet point, first sentence is highlighted. High output or HO lamps is a group of rapid start lamps that produce higher light levels by operating higher operating current, so 800 milliamps to 1,000 milliamps or an amp. And then the last bullet point in the top right of page 11 is also an online test question. So T5 lamps. T5 lamps are newer and more energy efficient lamps than T8 or T12. They can only be used with electronic ballasts and produce nearly twice the light output of a traditional T8 or T12. So up above that, right, T12 are the oldest. So T12 are the oldest. So I think they divide, although I think this is a highlight coming up, but I think you divide by 12 to see how much of a diameter the bulb is. So you can see a T5 would be like almost half an inch, where a T12 would be a full inch in diameter. So the smaller they are, the newer they are, the more efficient they work. But you need to know T5s are the newest, and then T8s are a little bit older, and T12s are the oldest. Light emitting diodes, 214. Like I said, these are everywhere now. Page 12, I've only got one highlight in there, and that's in the bullet points in the bottom right of the page. The advantages of LED lamps include the following. I've got the 5th bullet point as an online test question. Repeated starts have no effect on the lifespan. So where you might have heard, like if you turn on the fluorescent lights, the worst thing for a fluorescent light is actually the act of coming up to up in power and stuff like that. It's harder on the lights. That's why a lot of times you see people or buildings where fluorescent lights are just left on, so that turning them on and off doesn't decrease the lifespan. But with LEDs, on off does not matter. You turn them on and off 1,000 times. Doesn't increase or decrease the lifespan. Going on from there to page 14, 215, high intensity discharge or HID lamps, 215. First bullet point, first sentence is highlighted for these HID lamps. Mercury vapor lamps. Mercury vapor lamps are the oldest of the HID lamp types. Mercury lamps are the oldest. Going over to page 15, the last bullet point. I've got a couple highlights in this last bullet point in this section. So the last big bullet point on page 15. Metal halide lamps. First sentence of that is highlighted. Of all the HID lamp types, metal halide lamps, also called multi-vapor lamps, have the highest CRI. Remember that CRI means color rendering index. Skip a sentence and I have the third sentence highlighted. Because of danger from arc tube rupture, NEC section 410-130F5 requires all metal halide lamps except thick glass PARs to either have a containment barrier, which is a lens, or be type O with a protected socket. So out to the side of that, I wrote explosion. You want to make sure they're kind of they have explode, like these bulbs can pop, so they usually have a lot thicker glass on the outside of them than normal bulb types. These are these are kind of what used to be in stadiums and stuff like that. You'll still see them. These are definitely older type bulbs that are definitely getting phased out by LEDs. Flipping over to page 16 and 17, you've got some other different other types of lamps, magnetic induction lamps, xenon arc lamps. I do not have any highlights in those, but definitely worth reading through some of the advantages and disadvantages of those. Components of luminaires, lamp shapes and dimensions, 221. Lamp shapes and dimensions, 221. Last two sentences on page 16 are highlighted going into page 17. Lamps are identified by a letter referring to their shape and a number that indicates their maximum diameter, stated in eighths of an inch. I was wrong. I thought it was twelfths. It's eighths of an inch. For example, in the United States, an A40 identifies a lamp with an A shape that is 48ths, or 5 inches in diameter. And a T12 is 12/8, or 1.5 inches in diameter. So where I said that was everything was divided by 12, it's not. It's divided by 8. So 12/8 would be 1.5 inches. A T8 bulb would be 8/8, which would be 1 inch. And then that T5 bulb would be, it's just so you know, it's shaped like it has a T shape, like you can see on page 17. And then the 5 means that it's 5/8 of an inch in diameter. You need to know that one. Going on to page 18, installing lamps, 223. I've got the fourth bullet point in installing lamps highlighted. Make sure that the maximum luminaire wattage rating is not exceeded by the replacement lamp or combination of lamps. Otherwise, the luminaire can overheat and may cause a fire. Increased luminaire or in recessed luminaires with built-in thermal protectors will cause the lamps to cycle on and off as the luminaire overheats and cools down. Put the wrong light bulb in there, it's not going to work right. Make sure you have the same bulbs. It's usually a wattage rating. You're looking at the wattage rating of the light. Make sure it's matching up with what you're replacing or what equipment you're using it with. 224 on page 19, fluorescent luminaire ballast. First sentence is highlighted on there. In fluorescent luminaires, the ballast perform the following functions. Second bullet point highlighted. It regulates electronic current flowing through the lamp to stabilize the light's output. Usually you have a high inrush current and then it steadies out pretty quickly. It's got to have that high voltage to get the particles inside moving, and then it balances out and gets you a stable light after that. On the right-hand side of page 19, I've got the second to last bullet point, not including, or second to last paragraph, not including the bullet point highlighted. Sentence right in the middle of that paragraph. So it's the paragraph that starts with electronic ballasts eliminate, but I guess it's the second sentence in that paragraph is highlighted. They are available to operate from 1 to 4 lamps. Second, third sentence. With electronic ballast, the power input is 50 to 60 hertz, but the ballast operates the lamps at 20 to 50 kilohertz. With resulting improvements in ballast and lamp efficiency and the elimination of audible hum and a lamp flicker. So these ballasts can control what the frequency is, and you can get away from hearing that high-pitched hum. I don't know if you can hear it through the video, but there's a high-pitched hum in this room because they switched these fluorescent bulbs to LED bulbs, and there's you can hear the high-pitched hum. Still going They start off with bullet points with different names for these ballasts. If you flip over to page 20, second bullet point, first sentence is highlighted. The electronic program start ballast. These ballasts offer the longest lamp life due to minimal cathode damage when starting, and nearly as great energy savings as instant start ballast due to reduced cathode heat. Make sure you have that highlighted. HID luminaire ballasts. These are the ballasts for an HID light. If you look over on, they have different categories of the ballast. On page 21, online test question, third bullet point, first sentence. 3 coil ballasts. These ballasts provide the best light output stability and dip tolerance during periods of voltage fluctuation. That is the 3 coil ballast. Online test question. Make sure you get that marked. LED drivers. So like I said, the driver is pretty much like it's not a ballast for LEDs, but it's doing the same function. 226 on page 22, first sentence is highlighted. LED drivers provide a stable source of power with a controlled DC voltage and or DC current. Last section, luminaires. You have one trade term, which is trophers, not highlighted, but recessed luminaires installed within the opening flush with the ceiling. So everything the bulb is in, like these ceilings that are on the ceiling, those are called trophers. So they're used to like reflect light in different ways from the bulbs. I've got nothing highlighted on page 23. They go through different types of luminaires and their applications. So flipping over to page 24 and 25. Page 25, only full paragraph, first sentence is highlighted. Other recessed luminaires called trophers are square or rectangular units installed above the ceiling. So that's what we have throughout the school. Those are trophers, like I just said. Flipping over to page 26 and 27, suspended luminaires. Full thing's highlighted, little 1-2 sentence section, 313. Suspended luminaires are hung from the ceiling using a chain, aircraft wire, cord, or metal stem. Included in this group are chandeliers and pendant units. Figure 26. So those are those chandeliers and pendant units like you see right here. So you have those a lot. You'll have those quite a bit in residential lighting and stuff like that, but definitely in big bays, even in cafeterias or gyms and stuff like that. Pole-mounted luminaires, flipping over to page 28. I don't have anything in pole-mounted luminaires, but those are just what you see usually on for street lighting and stuff like that. Flipping over to page 28, storing and handling lamps and luminaires. Not the most exciting stuff in the world. Fifth paragraph, about halfway through the fifth paragraph, I've got 2 separate highlights. The first one is most cartons can be opened using a utility knife with a short blade. Okay. The next sentence is a separate highlight. When handling the luminaire itself, wear gloves in order to prevent any grease, dirt, etc. on your hands from getting on the finished and or decorative surfaces to protect your hands from cuts or sharp edges or corners. It's also, like I've talked a lot about these light bulbs getting super hot. If you have oil, you always have oil and grease on your fingers, and if you touch these bulbs, that grease gets on there, and if it heats up, you can boil it, and it can actually change. It gets really hot on that part of the glass, it can actually break the glass as it gets hot. This is extremely important with like car headlights. Like if you're ever installing your car headlights, you don't ever want to touch that bulb with your fingers. And if you do have to, you want to get a rag or something, make sure you clean that off. But you want to try not to touch it with your fingers, or put some type of glove on so that you're not getting your grease on the bulbs. Installing luminaires. Last paragraph on page 29, first sentence. Article 410 sets forth the most requirements pertaining to the installation of luminaires in the National Electric Code. Flipping over to page 30, surface-mounted luminaires. So these are anything that are mounted on the surface, like you can see a couple of or at least one of them in here. A lot of times the emergency exit lights are a surface mounted luminaire. Whereas these ceiling lights in here are recessed because they're inside the ceiling and they're flush with the surface. But my highlight for surface mounted luminaires is on page 31. That last paragraph, second sentence is highlighted. When mounting luminaires that weigh more than 50 pounds on a ceiling, NEC section 314.27A2 requires that the luminaire be supported independently of the box unless the outlet box is listed for not less than the weight to be supported. So I've seen this done. Usually I'll just try to find a box that can support that amount of weight, or you actually string something through the box and you tie it to a rack or something like that. I've done, I think, all of one ceiling fan that somebody bought that had like a large electrical motor. It looked like an airplane propeller type ceiling fan, but it was very heavy, and I had to run through the box and actually tie off to a roof rafter to hold that weight because the box was already installed. I couldn't change the box, or I couldn't easily change the box. It was easier to run my cables through and make sure I was secured. Flipping over to page 32 and 33, they go through some of the different considerations to think of when you're installing these. What I tell everybody is, yes, it's nice to be able to just open the box, put something together, and install it. But if it's not a especially brand or type of light that you can install, read the instructions. Go through. A lot of times you do these jobs and you do. You're not just putting in one type of light in one place. It's one type of light in 30 places. So read the directions the first time you do it. That way you can get a feel of how to do it. Especially with like ceiling fans and stuff like that. I've put together a whole ceiling fan and then realized I had to take parts off of it to get it to go, to get other stuff put on. And that's because I didn't read the directions and I was just trying to go quick. Read the directions when putting up these lights. Make sure you know how to put everything together from start to finish. Read the directions before you even start putting them together. But no highlights on 32 and 33. Just read the directions. 34 and 35. Again, it's talking about installing stuff. The figure attaching chandeliers to an outlet box, that's actually a pretty good one, especially because you have to run the wires up through those chains quite a bit, and you definitely don't want to be twisting that chandelier tighter to the ceiling. After you get the wires ran, you want to make sure the height and stuff is where you want it, and then run your wire. I've run into this. You run the wire first, and then you need to go up a little bit higher, so you have to twist everything. That wire twists inside of the chain. Don't put the wire in until you have it at the correct height, and then run the wire. And trust me, that makes it way easier. But no highlights in 34 and 35. Going into pages 36 and 37. On page 36, this is recessed luminaires. First paragraph, second sentence is highlighted. Properly supported outlet boxes are placed above the ceiling and separated by a minimum distance of at least a foot. These recessed luminaires are separated by a foot. So they have some of the rules up there in the top right on page 37. So this picture right here, I've got that all the way in the top. I don't know if you can see this up on the board. You probably can't. Top right of that picture on page 37, I've got that note highlighted. Fixture width must be at least 18 inches, but not more than 6 feet of suitable raceway, with conductors having insulation suitable for the temperature encountered. This is found in NEC section 410.117C. So that just means that this width going to a box can't be more than 6 feet, but it has to be at least 18 inches. Moving on to page 38 and 39, suspended luminaires on page 39. First sentence is highlighted in 333. Suspended luminaires used in commercial and industrial buildings can be supported in numerous ways from the building's structural members, depending on the construction of the building and the lighting application. So sometimes these can lay right in the ceiling, sometimes these clip to the ceiling grid, sometimes they're actually hung to something else. Just know that there's different ways to hang up these recessed luminaires. You can see these little clips on the side. In all honesty, these are a complete pain in the butt. Installing, not so much. Trying to change them out, they are a pain in the butt if you don't know where they are. But just know that there's different tools and parts that can help hang these lights and stuff. Flip over to page 40. You can see a bunch of different types of hangers used to attach in industrial buildings. So just know you have a wide plethora of different ways to attach these. And then page 41 shows different methods of attaching suspended luminaires. Now, I don't have any highlights in 40 and 41, but good to know that those are out there. Page 42 and 43, some luminaire supports for commercial or industrial type. I do have a highlight on page 43, first paragraph, last sentence. When installed on a wall, the track, let's talk about track lighting. The track must be at least 5 feet above the finished floor, 5 feet above the finished floor for track lighting, except for protected from physical damage or when low voltage, we're using low voltage track. At least 5 feet off the ground. Flipping over to page 45, making electrical connections to luminaires. So actually wiring this stuff up. Third paragraph, right after the warning on page 45. First 2 sentences are highlighted. When cutting outlet box wires in preparation for connecting luminaire, do not cut the branch circuit wires too short or too long. NEC section 314 requires at least 6 inches of free conductor left at each outlet box or where it emerges from its cable sheet or raceway. Usually what I do to make sure I have 6 inches, I know on my hand, I know that like from the bottom of my hand to my thumb is close to 6 inches. So usually I'm just grabbing that wire at the wall, sticking my thumb out, and then cutting it at the end of my thumb. That way I know this is a little bit longer than 6 inches, but it gives me at least enough to, if I mess up, say I messed up stripping my wire or something like that, I can trim a little bit more off. The biggest thing is you want to make sure usually you have 3 wires, maybe 5 or 6, depending on if they're running somewhere else. But you want to make sure they're all the same length. You don't want to try to have 3 different lengths of wire and you're trying to butt them all together. Pull them all out there, make sure you have 6 inches, cut them all off together, then strip them. And it's way easier to get those wire nuts on whenever those wires are the same length rather than a few different lengths. Page 46. Modular system wiring. You can see this. This is something, if I'm being honest, I've never had to mess with. I've seen this stuff before, but usually it's just kind of plug and play stuff. I've never installed it, but it's pretty simple to use. You just kind of have a locking clip, unplug it, and then plug it back in. It's kind of made for a specific system or purpose, wherever it's put in. But I have an online test question on page 46. In that first bullet point, modular system wiring, I think it's the 3rd sentence. Modular system components are interchangeable and can be reused. Component labels are color-coded by voltage, and the units are keyed to prevent mismatching. So you can't actually plug in something that's not the right voltage. Makes it very easy. If I had to guess, these are very, very expensive. But that's all my highlights for this chapter. So you got the section reviews, the module review, you got some supplemental exercise, and then the quiz that will be online.